Okay, today we will introduce the variants of discrete random variables. Firstly, we will review the last class. In last class, we introduced the mean of random variables. Okay, the mean or the mathematical expectation of the discrete random variable x, ex, which is equal to sigma I, which is from 1 to n xi times pi, reflects the average level of the values of the discrete random variable. Okay, now in this class, we see an interesting question: how to choose a student. One student should be selected from the two students to represent the class in the shooting competition. Okay, based on the previous performance record, the distribution of the number of rings x1 and x2 hit by the first student and the second student on the target is as follows. These two lists. Which students should be sent to participate in the competition? In last class, we learned the mean of the random variable. So we know in this question, if the mean of rings higher, maybe these students would get a better grade in the competition. So first, we calculate the mean of these two students. Okay, but now we calculate the mean. We found the EX1 and the EX2 are both 8, so we meet a difficult. The shooting levels of these two students cannot be distinguished only based on the average value. So now how to choose a student to represent our class? So apart from the mean value of target rings hit, are there any other method to describe the shooting characteristics of each of the two students? Now we make the date into a column graph. We can see that the student one, his grade uh, is not uh, concentrated. Is not concentrated beside the mean value 8, but student 2, his grade is concentrated beside near the mean value 8. So compare the two distribution column graphs, we can find that uh, student the second student are more stable than the first student. Okay, so we can so in this sample we can find how the stable is another characteristic of random variables. But what is stable? It can be described uh, described as the date uh, uh, the date from the mean value uh, is the deviation from the mean value. So in this class we need to research how to describe the deviation. Okay, EX is the mean value give us a representation of the average value. So from the previous example, we know that the characteristics of a random variable cannot be fully described only by the mean value. So we need so now what we pay attention to is the deviation from the x. It describes the stable of the random variable. Similar to EX, we also want to describe this deviation with a number. Okay, firstly, so now we need to consider how can we describe the deviation. Okay, similarly, first we can find the way similar to the mean value. It's the summation these deviation values, but from the properties of mean value, we can find sigma I from 1 to n xi minus ex times pi, which is equal to 0. So these properties comes from mutual cancel cancellation of positive and negative deviations. So we immediately find that this attempt is meaningless. So now we need to change our way to describe the deviation. Okay, so we notice that uh, this this way is meaningless because of the cancellation of positive and negative deviation. So to prevent the positive and negative aspects from canceling each other out, we try to use absolute deviation to define the to describe the deviation of random variables, which is equal to sigma I is from 1 to n absolute value xi minus ex times pi. We can find that this method can well describe the degree of deviation from the mean value. If this value higher, it means the random variable is not stable from the mean value. But in mathematics, absolute values are not easy to handle in some real problems. So finally, mathematicians use the square of the deviation to describe the degree of deviation from the mean value. We call it the variance. Now we give the definition of the variance. Okay, then the distribution list of the discrete random variable x. Now we by the previous analysis, we know that the square of xi time minus ex describes the degree of deviation of xi from the mean ex. So we define dx, which is equal to sigma I from 1 to n, the square of xi minus ex times pi is the weighted average of these degrees of deviation, characterizing the average degree of deviation of the random variable x from its mean ex. We call dx the variance of the random variable x. Okay, and its arithmetic square root is the standard deviation of the random variable. We denote it as sigma x. So we know the define of the variance. Now we need to learn how to calculate the variance. Okay, from we use the previous example date to learn how to calculate the variance. Firstly, okay, if we need to calculate the variance, we need to calculate the mean of the random variable first. Okay, first we calculate the mean. EX1 and EX2 are both equal to 8. Now we use we and now we replace the real date into this volume, so we get the dx 1, which is equal to 1.5, and the x2, which is equal to 0.82. Therefore, the shooting score of the first student was relatively unstable, while that of the second student was relatively stable, around 8 point. It's its mean value. Okay, and then finally, we need to know what is the meaning of the variance. The meaning of the mean value that describes the average level of random variable, but the variance and the standard deviation of a random variable both reflect the average degree to which the value of the random variable deviates from the mean. The smaller the variance of a standard variation is, the smaller the average degree to which the random variable deviation from the mean. So the previous example, we we know that because the variance of student two, the second student two is smaller, so it means the student two is more stable in the competition. So it means student two, uh, it, it so it means the student two would get the better grades in the competition than student one. Okay, finally, we also introduce more difficult problem. It's about how to choose a student in a competition. If the shooting scores of the contestants from other class are all around 9 points, so in this case, which students should our class send to participate? And in the second case, if the scores of the contestants from other classes are around 7 rings, which students should be sent to participate? Okay, first, we look at we look at uh, these two column graph. We can find that if the if the contestants in other class are 9, so if we want to win this game, we need to get the 10 score so that we could win this game. So student 1 and student 2, we can find student 1, although uh, he is unstable, but has he has more probability than student 2 to get the test score. But if the okay, in second class, in second case, if the score in other class are 7, so we only need to get 8, so that we could win this game. So we can find the student 2 have bigger probabilities than student 1 to get the higher score than 7 because he's more stable. So for the first case, the greater the probability. So for the first case, greater the probability that the score exists 9, the better. Therefore, we choose student 1. For the second situation, we need students whose score are as unlikely as possible to be lower than 8. That is, more stable ones. Therefore, we choose student 2. So uh, we use meaning or variance to describe our random variance. We need to consider the different situation and so that to make a correct decision in the real situation. Okay, and this is my introduce to the variance of random variable. Thank you for your listening.